Hello everyone, welcome back to my channel. I am Vandana, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Information Science and Engineering, first sem ECHA section. Today in this video, we are going to learn about the subject mathematics, particularly about the topic linear algebra. Contents for the selected topic are definition of linear algebra, introduction to linear algebra equations, elementary linear algebra applications, and solved problems based on Gauss elimination method. Now let's come to the definition. Linear algebra, a branch of mathematics dealing with vector space and linear mappings between these spaces, plays a critical role in various engineering fields. Introduction to linear algebra. Linear algebra is the study of linear combinations. It is the study of vector space, lines and planes, and some mappings that are required to perform the linear transformations. It includes vectors, matrices, and linear functions. It is the study of linear sets of equations and its transformation properties. Linear algebra equations. The general linear equation is represented as a1x1 plus a2x2 up to an(xn) equals b. Here a represents the coefficients and x represents the unknown, b represents the constant. There exists a system of linear algebraic equations which is the set of equations. The system of equations can be solved using the matrices. Elementary linear algebra. Some important terms associated with elementary linear algebra are given below. Scalars. A scalar is a quantity that only has magnitude and no direction. It is an element that is used to define a vector space. In linear algebra, scalars are usually real numbers. Vectors. A vector is an element in a vector space. It is a quantity that can describe both direction and magnitude of the element. Vector space. The vector space consists of a vectors that may be added together and multiplied by scalars. Matrix. A matrix is a rectangular array wherein the information is organized in the form of rows and columns. Most linear algebra properties can be expressed in terms of matrix. Matrix operations. These are the simple arithmetic operations such as addition, subtraction, and multiplication that can be conducted on matrices. Now let's come to linear algebra applications. Here some of the linear algebra applications are given as linear programming. Optimization is an important application of linear algebra which is widely used in the field of linear programming. Prediction. Predictions of some objects should be found using linear models which are developed using linear algebra. Graphics. An important part of graphics is projecting a three-dimensional scene on two-dimensional screen which is handled only by linear maps which are explained by linear algebra. Gauss elimination method. This method is illustrated by considering a system of three independent equations in three unknowns. This system is equivalent to the matrix equation Ax equals b. Solving the system of equation by Gauss elimination method, and the equation is x plus y plus z equals 9, x minus 2y plus 3z equals 8, and 2x plus y minus z equals 3. By collecting all the values, we have to make these three elements 0. To make these elements, we have to do R2 equals R2 minus R1 and R3 tends to R3 minus 2R1. By this, the value of this element be 0 and remaining is this element. To make this element 0, we have to do R3 tends to 3 R3 minus R2, then all three elements be 0. Then we have to find the xyz values. Further, the system of equation is x plus y plus z equals 9 and minus 3y plus 2z equals minus 1 and the minus 11 z equals minus 44. From this equation, see 11z equals minus 44, z equals minus 44 by minus 11 and the z value is 4. From equation B, minus 3y plus 2z equals minus 1. Replacing the z value, minus 3y plus 2 into 4 equals minus 1 and y value is 3. And from equation A, x plus y plus z, replacing the y and z value, and the y value is 3 and the z value is 4. Replacing that, x plus 3 plus 4 equals 9 and then x value is 2. We got x equals 2, y equals 3 and z equals 4. Thank you for watching this video.